The ambiguous case. How many triangles can be constructed if you have an angle that's 44, which we're calling angle A, the side opposite that, I might as well label as I go, 44, the side opposite that is 11, so that's 44 degrees, side C is 7, and how many angles can be constructed from this information? Our possible answers are 0 triangles, 1 triangle, or 2 triangles. So these are the only possible answers we could have here. And we use law of sine to help us figure this out. If you remember, law of sine involves an angle, the side opposite it, an angle on the side opposite it. What we have here is the side opposite, and we don't have angle C. And so this is law of sines, but we're using it to find an angle as opposed to a side. And we'll see why it's called the ambiguous case, because finding that angle, sometimes there's more than one angle that could work. So let's get started first with law of sines. We see a side, and the angle across from it would be sine 44, and a side and sine C. Cross multiplying here, we will get 7 sine 44 equal to 11 sine C, and then we need to solve for sine C, so we're going to divide by 11, and my calculator can help me a lot here. So let's do 7 times sine 44 divided by 11. And so the answer is 0.4420, and I'm going to use 4 decimal places here, 0.4420. That's sine C equals 0.4420. Now, it's good that that's between 1 and -1. If you remember from previous lectures that sine and cosine cannot be larger than 1 or -1 when they're in decimal forms. So if you ever get sine C equals 1.7, right away you know the answer is 0 triangles. So that's a good thing to remember. But because it's less than 1 and greater than -1, we know that we can go forward, and we'll probably have at least 1 triangle. Now I have function and 0.4420 is my ratio. I need to find angle C, so arc sine or inverse sine of this value will give me angle C. And so I'll do second sine, second answer. This way I know I'm very much exact with my decimal. And we'll go to the nearest tenth, so 26.2. So angle C is 26.2 degrees. Now here comes the ambiguous part case. Because sine is 0.4420 and our calculator is telling us it's 26.2, we know that when we have a ratio and we're finding an angle, we almost always have 2 angles that have the same ratio, because sine is also positive in the second quadrant, and your calculator just gives you the first quadrant answer. So 26.2 is an answer, or let's say a possible answer, in quadrant 1. The quadrant 2 angle for C would be 26.2, let's say minus 180, and then divide by -1 is 153.8. So 153.8. So these are your 2 possible values for sine. Now we do know one angle measurement. Angle A is 44. Now let's use these possibilities to find out what the option for angle B could be. So we know 3 angles of a triangle have to add to 180. So let's see, our first option is going to be, so let's clear this, 180 minus 44 minus 26.2 is 109.8. So angle B could be 109.8. So we could form a triangle with those angle measurements that satisfy what we were given. Let's look at our other option. 180 minus angle A is 44 degrees minus the possible angle for C, 153.8, and we get negative 17.8, and we cannot have a negative angle, so therefore that triangle does not work, and there is only one triangle that can be constructed with these numbers. So what happens is when you get angle C, you get the reference angle for angle C in the second quadrant, and you test them both out with the angle you already have to see if it fits into the three angles of a triangle. Sometimes it fits in both and the answer is 2. Sometimes it fits in only 1, the answer is 1. Sometimes you get a value that just doesn't work in either and the answer is 0.